Students, now let's go to question number 22. It says find the square root of z is equal to 1 plus radical 3i. So we are going to now calculate a complex number that can make 1 plus radical 3y when it is multiple twice. So this is our first task, and next we are asked to find the solution or to solve this equation, z squared minus into 1 plus radical 3i equals 0 in the set of complex number. So as usual, let's begin our solution from A. So you are given a complex number 1 plus radical 3i. Now you need to recall the extraction of roots formula, the one we did inside the classroom. So if you remember, the formula was written as ck equals r to the power of 1 over n e to the power of theta plus 2k pi over n I, k running from 0 up to n minus 1. Look, in the case of this, we are looking for a square root. So when we are looking for the square root, our n value is 2. So put here 2, 2 minus 1 is 1. So our k is going to run from 0 up to 1. Since we are looking for a square root, we do have two complex number values. So we consider these two complex number values as C0 and C1 because 2 minus 1 is 1, it ends here. So we'll never consider 2, 3 and more than that. So we do have two options where we do have two different roots where we can have solution for the letter A. So the first is a case where k is 0. And the second is a case where k is 1. But before that, we need to determine r and theta. How is r obtained? R is nothing but it is a square root of the sum of the square of the real as well as imaginary one. And how can we determine theta? Theta is nothing but it is the angle existing between the positive real part or real axis and the complex plane. And the complex number on a complex plane. So here we are having radical 3 and 1, radical 3 divided by 1. What is that? It is radical 3. So think of an angle whose tan can be radical 3. Clearly it is 60 degrees. So the equivalent radian measured for 60 degrees is pi over 3. So look, our r is obtained here. It is number 2 and theta is pi over 3, 60 degrees. So once we have these two values, we just plug them where in our formula here. So in place of n, you are supposed to take 2 because you are looking for square roots. You do have n to be 2 always. And r is 2 and theta is pi over 3. So next from this we have this one, ck is equal to 2 to the power of 1 over 2. I just directly substitute number 2 in place of r as you see. And n is 2, so 2 to the power of 1 over 2. Is a power of what is theta? Theta is, as I said earlier, is pi over 3. So is a power of pi over 3 plus 2k pi I over 2. You see, over 2 because our n value is 2. So to the power of 1 over 2 makes radical 2. And this is 3 pi over 6 because 3 multiples 2, pi over 6 can come. Here 2 cancelled by 2, k pi can come. So these are, you see, our possible k values 0 and 1. So using this we can determine the square root of this one. So let's start from k is equal to 0. Now students, you simply put 0 in place of k here. It's going to be c0. K, put k again here 0. So again I hope this term is eliminated. So you are having only what? Theta alone, theta over n. So here it is. For k equals 0, c0 is given by this one. So 2 times 0 is 0, so the whole goes to 0, this 1 goes to 0. Then radical 2 is a power of pi over 6 can come, you see, pi over 6i. We know that pi over 6 radical is the same as 30 degrees, so we can have this as you see. Radical 2 cosine of pi over 6 plus I times sine pi over 6. We knew that this is cosine 30 degrees, which actually is radical 3 over 2, and this is again sine 30 degrees, which actually is what, students? Radical 3 over 2. This one is 1 over 2. And this is, cosine 30 degrees is radical 3 over 2 and sine 30 is 1 over 2. So now proceeding to the next one, we have here radical 2, radical 3 over 2 plus 1 over 2i. So multiplying radical 2 with radical 3 makes radical 6 plus radical 2 over 2i. We have this, okay? So what do you mean by saying this? This means if you multiply this twice, believe me, you will obtain 1 plus radical 3i. That is the idea. Multiply this one twice, you will obtain 1 plus radical 3i. Multiply radical 6 over 2 plus radical 2i. Again, with radical 6 over 2 plus radical 2 over 2i, you will obtain that to be 1 plus radical 3i. It is in this way that you need to recheck. So one possible root is obtained. What about the other? We can have that one. Dear student, let me tell you one important tip. As you are calculating the nth root of a certain complex number, student, you have to know that there will exist any number of, you see, any number of roots. For example, if you are interested to find the 6 roots of a certain complex number, know that the complex number will have 6 different complex values called complex numbers, you see, as a root value. So keeping on, for the next one we have k to be 1 because we are looking for square roots. So for k is equal to 1, look, in place of k you're having 1, the rest are as they are. Theta pi over 3 is as it is. Here we are having 2 because we are looking for square root, and this is, you see, to the power of 1 over n is 2. We have this 3 times 2 makes 6, 6 with 1, 7 pi over 6 I radical 2 can come. As I said earlier, 7 pi over 6 is the same as negative cosine pi 6 plus I times sine pi over 6. So this is going to be equivalent to like this, but as I said, this is the same as cosine of, you see, cosine of what, student? Cosine of 30 degree, but having minus in front because this is a second quadrant angle. It's having negative angles, so negative measures, so we have minus radical 3 over 2. Coming to this is sine 30, which actually is 1 over 2, but it has to be negative because this angle is lying in the third quadrant. So we have this. So this enables us to know the second root for this complex number. Look, radical 2 times minus radical 3 is minus radical 6, and minus radical 2 over 2. Basically, this is feasible. Reason? Because if a number is a square root of a certain number, then the negative of the first number can also be the square root, because when you square negatives, you see, nothing is going to come. It is the expression as it is going to come, okay? So you need to know that. So what have you obtained? K values are obtained, and because of these K values, because of these given K values, we have determined these two complex numbers. So these two complex numbers are square roots for 1 plus radical 3i. You can check this one just multiplying these two again and again, so you will get the answer to be 1 plus radical 3i. So coming to the second one, it says solve the system z squared minus into 1 plus radical 3i. So the solution for this is the solution for z squared equals 1 plus radical 3i, because it's a matter of taking this negative expression to the right. So as you are taking this negative expression to the right, what is going to come is z squared is equal to the one I wrote here. d squared is equal to 1 plus radical 3i. 1 plus radical 3i. So as I said earlier, we have two different roots, as you see. So these are going to be our this equation solution. And when you come to this one, d squared equals 1 plus radical 3i. I mean, yeah, when you come to this, you have, you see, two solutions, as you see. These two are our solutions. So this is what's meant by the solution of what? The solution of B. So nothing is done because z squared minus 1 plus radical 3i equals 0. From this we have z squared equals 1 plus radical 3i, and from this z squared equals 1 plus radical 3i, we need to find a complex number whose square can make 1 plus radical 3i. So this by itself requires, you see, the square root of 1 plus radical 3i, but this square root of 1 plus radical 3i is nothing but it is a first question, as we did here, and this makes what? These two to exist, and hence the solution for this one is again those we obtain here. Thank you.